Hello students, in this video, let's summarize Class 10 Science Chapter Light, Reflection and Refraction. What is reflection of light? Reflection of light occurs when light waves bounce off a surface. Highly polished surfaces, like mirrors, are excellent reflectors of light and can reflect most of the incident light. The laws of reflection of light include the angle of incidence is equal to the angle of reflection. The incident ray, the normal, perpendicular line, to the mirror at the point of incidence, and the reflected ray all lie in the same plane. These laws apply to all types of reflecting surfaces. There are two main types of reflecting surfaces, plane mirrors and spherical mirrors. Let's discuss them individually. Plane mirrors. Plane mirrors are common examples of reflecting surfaces. The properties of an image in a plane mirror are: it is virtual, meaning it cannot be projected on a screen. It is erect, maintaining the same orientation as the object. Its size is the same as that of the object. It appears as far behind the mirror as the object is in front of it. It is laterally inverted, where left and right sides are swapped. Spherical mirrors. Spherical mirrors are a common type of curved mirror with reflecting surfaces shaped like a part of a sphere. Concave mirror. A spherical mirror with a curved reflecting surface that faces inwards towards the center of the sphere. Convex mirror. A spherical mirror with a curved reflecting surface that faces outwards away from the center of the sphere. Let us understand some basic terms related to spherical mirrors and image formation by them. Pole. Pole is a specific point on the reflecting surface of a spherical mirror, typically represented as P. Center of curvature. Center of curvature is a point located outside the reflecting surface of a spherical mirror, denoted as C. For a concave mirror, it lies in front of the mirror, while for a convex mirror, it lies behind the mirror. Radius of curvature. Radius of curvature is the distance from the pole of a spherical mirror to its center of curvature, C. Principal axis. Principal axis is a straight line passing through the pole and the center of curvature of a spherical mirror, which is perpendicular to the mirror at the pole. Principal focus. For a concave mirror, it is the point where parallel rays of light converge after reflecting. For a convex mirror, it is the point from which parallel rays of light appear to diverge after reflection. Focal length is the distance between the pole and the principal focus of a spherical mirror. Relationship R is equal to 2F. This mathematical connection between the radius of curvature, R, and the focal length, F, of a spherical mirror indicates that the principal focus is located equidistant from the pole and the center of curvature. Let us now understand the image formation by spherical mirrors using ray diagrams. Ray diagrams are used to depict the image formation by tracing the path of light rays, that is incident rays and reflected rays. Here are some general rules for image formation using ray diagrams. Any incident ray of light that is parallel to principal axis always passes through the principal focus of the mirror after reflection. Any ray of light that passes through the principal focus reflects parallel to the principal axis. A ray of light passing through the center of curvature of any mirror is reflected back along the same path. Any diagonal incident ray also reflects diagonally, and the angles formed by these rays are equal to each other. Ray diagrams for a concave mirror. For a concave mirror, there are 6 possible positions where the object can be positioned and an image is formed. When the object is placed at infinity, real, inverted and smaller image at focus is formed. When object is placed beyond center of curvature, real, inverted and smaller image between focus and center of curvature is formed. When object is placed at center of curvature, real, inverted and same size image is formed at center of curvature. When object is placed between center of curvature and focus, real, inverted and larger size image is formed beyond center of curvature. When the object is at focus, no image is formed. When object is between focus and the vertex, virtual, a bright and larger image is formed behind the mirror. Having gained an understanding of how concave mirrors form images, let's promptly delve into the practical applications of these mirrors. Concave mirrors are commonly used in torches, searchlights, and vehicles' headlights to get powerful parallel beams of light. They are often used as shaving mirrors to see a larger image of the face. The dentists use concave mirrors to see large images of the teeth of patients. Ray diagrams for a convex mirror. In case of a convex mirror, there are only two possible positions where the object can be positioned and an image can be formed. When object is positioned at infinity, virtual, erect and highly diminished image is formed behind the mirror. When object is positioned between the pole and the principal focus, virtual, erect and small image is formed behind the mirror between the pole and principal focus. Uses of convex mirrors. Convex mirrors are commonly used as rearview mirrors in vehicles. These mirrors are fitted on the sides of the vehicle, enabling the driver to see traffic behind him to facilitate safe driving. Convex mirrors are preferred because they always give an erect, diminished image. Mirror formula and magnification. What is mirror formula? The mirror formula serves as a tool for determining the image distance, denoted as v, the object distance, denoted as u, the focal length, denoted as f. This formula is valid for all kinds of spherical mirrors, for all positions of the object. Although one needs to be careful about the values one puts for u, v and f with appropriate sign according to the sign convention. Sign convention for spherical mirrors. The sign convention for spherical mirrors follows a set of rules known as the New Cartesian sign convention. New Cartesian sign convention is used to avoid confusion in understanding the ray directions. Refer to the diagram to get a clear idea. For the measurement of all the distances, the pole of the lens is considered. When the distances are measured opposite to the direction of the incident light, they are considered to be negative. When the distances are measured in the same direction of the incident light, they are considered to be positive. When the heights are measured upwards and perpendicular to the principal axis, they are considered to be positive. When the heights are measured downwards and perpendicular to the principal axis, they are considered to be negative. What is magnification? It is defined as the extent to which the image appears bigger or smaller in comparison to the object size. Magnification is represented as the ratio of the height of the image to the ratio of the height of the object. Magnification is denoted as the letter M. Magnification can also be related to the image distance and object distance, therefore it can also be written as -v by u. So, till now, we have covered about reflection of light, which is how light bounces off surfaces. Now, let's learn about refraction of light, or how light bends when it passes through things. What is refraction of light? The change in the direction of a wave when it passes from one medium to another is known as refraction. The refraction of light occurs when a light wave, incident at an angle away from the normal, passes a boundary from one medium into another in which there is a change in velocity of the light. Laws of refraction of light. When the incident light is perpendicular to the boundary, refraction of light is not possible. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. This is also known as Snell's law of refraction. What is refractive index? The refractive index, also called the index of refraction, describes how fast light travels through the material. Larger refractive index means denser medium, and the speed of light is higher in a rarer medium than a denser medium. Order of refractive index of glass is greater than water, which is greater than air. This means speed of light will be opposite and will be greatest in air, then water, and will be least in glass. The refractive index is dimensionless. For a given material, the refractive index, n, is the ratio between the speed of light in a vacuum, c, and the speed of light in the medium, v. Let us now see the practical applications of refraction by understanding the image formation by spherical lenses. Spherical lenses are lenses formed by connecting to spherical transparent surfaces. In general, there are two types of spherical lenses. So, lenses formed by binding to spherical surfaces bulging outward are known as convex lenses, while the lenses formed by binding to spherical surfaces such that they are curved inward are known as concave lenses. Image formation by convex lenses. When an object is placed at infinity, the real image is formed at the focus. The size of the image is highly diminished and point size. When an object is placed beyond the center of curvature, the real image is formed between the center of curvature and focus. The image size will not be the same as the object. It will be diminished in size. When an object is at the center of curvature, the real image is formed at the other center of curvature. The size of the image is the same as compared to that of the object. When an object is placed in between the center of curvature and focus, the real image is formed behind the center of curvature. The size of the image is larger than that of the object. When an object is placed at the focus, a real image is formed at infinity. The size of the image is much larger than that of the object. When an object is placed in between focus and optical center, a virtual image is formed. The size of the image is larger than that of the object. Image formation by concave lenses. When an object is placed at infinity, a virtual image is formed at the focus. The size of the image is highly diminished and point size. When an object is placed at a finite distance from the lens, a virtual image is formed between the optical center and the focus of the convex lens. The size of the image is smaller than that of the object. So, with the completion of this video, we have addressed all the important topics of Class 10 Chapter Light, Reflection and Refraction. You can learn this chapter through topic-wise video lectures, MCQ tests, and revision notes available in EduRev app.